Hi students, today in this videos we will discussing the topic is residues of a function, that is residues of a given complex variable function. So in the previous lecture we will discussing the topic is zeros and singularities. Okay, now we are finding how to finding residues and what is the definition of residues of the given function. Okay, first of all see the definition. So we know that the Lorentz series of expansion of f of z about z is equal to a. This is a Lorentz series, and so this is the expansion of first part, positive powers of z minus a. The second part is negative powers of z minus a. So where an is equal the coefficients, the first one how to finding an, and n is equal 1, 2, 3 substituting a1 finding, a0 finding, a1 finding, a2 finding up to so on using this formula. And in this one finding the coefficients of b, the b1, b2, b3 up to finding. This is bn is equal to. Okay, na? This is the, we know that Lorentz series expansion of given function. Okay, now so and the definition of residue is the coefficient of 1 by z minus a in the Lorentz series expansion of f of z is known as residue of f of z at z is equal to a. And only second part చూడండి, z minus a is a negative powers కదా, అందులో ఓన్లీ ఫస్ట్ టర్మ్ అంటే 1 బై జెడ్ మైనస్ ఏ. ఇప్పుడు ఎక్స్పాండ్ చేయండి, ఏమొస్తుంది b1 ఇంటూ 1 బై జెడ్ మైనస్ ఏ ప్లస్ b2 ఇంటూ 1 బై జెడ్ మైనస్ ఏ హోల్ స్క్వేర్ ప్లస్ b3 ఇంటూ 1 బై జెడ్ మైనస్ ఏ హోల్ క్యూబ్ అప్ టు సోని కదా. బట్ ఓన్లీ ద ఫస్ట్ టర్మ్ కోఎఫిషియంట్, the coefficient of 1 by z minus a is b1. The b1 is called residue of given function f of z. అంటే b1 ఎలా ఫైండ్ అవుట్ చేస్తుంది, ఇది రెసిడ్యూ అండి. ద కోఎఫిషియంట్ ఆఫ్ 1 by z minus a in the Lorentz series is called residue of f of z about, that means at the point z is equal to a. A is the given center, అవునా. So this is the residue of a function. This is the definition. Okay, so that is residue means the coefficient of 1 by z minus a, that is b1. b1 is the residue. How to finding b1 in this formula lo b n place lo 1 replacing, avuna, that is equal ఏమొస్తుంది 1 by 2 pi by I integration over c f of z. అంటే n is equal 1 కదా, అంటే z minus a power 0 అవుతుంది. అంటే z minus a power 0 means 1, అంటే by 1 into dz. This is the residue of the given function f of z. Okay, so this is the definition అండి. So then how to finding residue of the given function by using the given procedure here. Okay, see the procedure. So that is evaluation of residues. First one, residue at a simple fold. అంటే simple fold means the fold is repeated one time, అంటే z minus a is repeated one time of the given function f of z. Then at the point z is equal to how to finding residue. So that is equal to here first one, if f of z has a simple fold at z is equal to a, then here given formula residue of f of z is a given function. The denotating residue is the denoted residue of f of z at z is equal to a. The given point z is equal to, the formula is, this is the formula, and limit z tends to a, z minus a into f of z. So f of z is a given function, so z minus is the given at the point z. Now finding the limit. So this is a limit value is called residue of f of z at the point z is equal to a, when the point is simple fold. Okay, so next one, if f of z is of the form f of z is equal to g of z by h of z, where g of z and h of z are analytic function at z is equal to a, and if h of a is equal to 0 but g of a is not equal to 0, then అంటే గివెన్ ఓకే ఇన్ కేస్ ద గివెన్ ఫంక్షన్ ఇలా ఇచ్చాడు అనుకోండి, అంటే u by v మెథడ్లో ఇచ్చాడు. సో g of z by h of z లో ఇచ్చాడు అనుకోండి. హౌ టు ఫైండింగ్ ద రెసిడ్యూ, దిస్ ఇస్ వన్ ఆఫ్ ది సెకండ్ ఫార్ములా. సో దట్ ఈస్ రెసిడ్యూ f of z at the point z is equal to a, that is limit z tends to a, g of z by h dash of z, and h dash means derivative of z. So ఇది at the point residue to finding when f of z in the form g of z by h of z. Okay, see the next one here. Yeah, residue at a pole of order m. In case the pole is repeated m times, ante z minus a power m, the pole is repeated a is m times, then how to finding the residue. So if f of z has a pole of order m, z is equal to a, then residue of f of z at z is equal to a, that is equal to formula 1 by m minus 1 factorial, and m is a is repeated m times 1 by m minus 1 factorial into limit z tends to a d power m minus 1 by dz power m minus 1 of z minus a power m into f of z. And that means this is the function z minus a power m into f of z is m minus 1 time differentiation, after that finding the limit value. So this is the residue of the given function at pole of order m. This is the procedure and to finding the residue of the given function. Okay, yeah, okay, see the examples here. Example, the first example, find the residues of f of z is equal to 1 by z square plus 1. So how to finding residue, first finding the pole. And what is the pole? Finding the singularities. How to finding the singularities, the pole, the function is not analytic when the denominator is 0. And how to finding the pole, the denominator is equal to 0 only, then finding the point, that point is called pole. Okay na, so that is equal to 0 అయితేనేమో how to finding the zeros, the numerator is equal to 0 అండి, అది మనం numerator 0 తీసుకొని zeros find out చేయాలి. సో అదే finding the singularities, how to finding the singularities, the denominator is equal to 0 తీసుకోవాలి. So then finding the singularities, that is a pole or any type of singularities. Okay, see that here. Solution, let f of z is equal to 1 by z square plus 1. So z square plus 1 also can be write the product of the two values z minus I into z plus I. For poles of f of z, assumption denominator is equal to 0. The pole find out చేయడానికి మనం denominator 0 తీసుకోవాలి compulsory, because that function is not analytic when denominator is equal to 0. So that is equal to here z minus I into z plus I is equal to 0. So that is z is equal to I and minus I. So that is equal to z is equal to I is the pole, minus I is the pole, and both are repeated one time. So both poles are simple poles. If now finding the residue of the given function at each pole I and minus I. The first one, we know that formula, residue of f of z at z is equal to a. So this is the formula and manaki already told in the previous slide. Residue of f of z is at z is equal to a, limit z tends to a, z minus a into f of z. Now at the point z is equal to I. So residue of f of z at z is equal to I, that is equal to limit z tends to I, z minus I into f of z. So f of z is equal substituting here function, given function 1 by z minus I into z plus I substituting. So that is equal to, so z minus I cancel, remaining 1 by z plus I gada. So z is equal to I replacing z plus I, that is 1 by 2I. So this is the required residue of the given function at z is equal to I. So similarly second residue of at the second pole minus I, similarly same finding. So same residue of f of z at z is equal to minus I, that is equal to limit z tends to minus I, z plus I, z minus a kada, a is equal minus I and z plus I into f of z. Now f of z substituting here. So that is z tends to minus I, z plus I into 1 by z minus I into z plus I. So here z plus I, z plus cancel. So 1 by z minus I, z plus lo minus I replacing 1 by minus I and minus 1 by 2I. So this is the residue of given function f of z at z is equal to minus I. This is first example to finding the residue of the given function. Okay. Yeah, see that next example here. Find the residues at poles of f of z is equal to z plus 2 by z plus 1 whole square into z minus 2. So first of all finding the poles. So to finding the poles, to assumption the denominator is 0. So that is equal to here given f of z is equal to z plus 2 by z plus 1 whole square into z minus 2. So clearly that function is not analytic at z is equal minus 1 and z is equal to is a clear. For poles of f of z denominator is equal to 0. That is equal z is equal to minus 1, 2 times repeated, minus 1 and 2. So here two poles minus 1 and 2 only, but minus 1 is the repeated 2 times and order 2 and z is equal to is the pole is simple pole. So z is equal minus 1 is the pole of order 2 and z is equal to is simple pole. First finding here, we know that formula at the simple pole formula, z is equal is a one time repeated, this is the formula. So z, at z is equal to, we have to finding. So residue of f of z at z is equal to, formula is limit z tends to 2 into z minus 2 into f of z. F of z is equal substituting here. So limit z tends to 2, z minus 2 into z plus 2 by z plus 1 whole square into z minus 2. So z minus 2 the cancel, remaining finding substituting z is equal to the remaining function. So that is z plus 2 replacing 4 2 plus 2 by 2 plus 1 whole square, that is equal to 4 by 9. This is the required residue of the given function at first pole, z is equal to 2. Okay. Remaining same finding at the other pole, z is equal to minus 1. So but z is equal minus 1 is not simple pole, is a pole of order 2. Okay na, using that formula here. So f of z has a pole of order m is equal to, ante order m kada, ante m is equal to 2 times repeated kabatti at the point z is equal to minus 1. So using that formula, idi formula andi avuna, the f of z has a pole of order m at z is equal to a, this is the formula. Ante ikkada m is equal to replace cheyali manam avuna. In this formula replacing a is equal to minus 1 and m is equal to 2 replacing, that is equal to, therefore residue of f of z at z is equal to minus 1, that is equal to 1 by m minus 1 kada, m is equal to 2 avuna, 1 by 2 minus 1 factorial into limit z tends to minus 1 and z tends to a kada, a is equal to minus 1. So here m minus 1 derivative ante ikkada 2 minus 1 kada, ante one time differentiation, d power 2 minus 1 by dz power 2 minus 1. So z minus a and a is equal to minus 1 kada, ante z plus 1, m is equal to f of z. F of z replace cheyali. So 1 by 1 factorial limit z tends to minus 1 that is equal to d by dz, one time differentiation. It is z plus 1 whole square into function, given function f of z, function z plus 2 by z plus 1 whole square into z minus 2. ఇక్కడ z plus 1 whole square is a cancel, అవునా? Remaining here limit z tends to minus 1 d by dz of z plus 2 by z minus 2. అంటే ఇప్పుడు డిఫరెన్షియేషన్ కదా, that is u by v method. This is u, this is the v, u by v method. Limit z tends to minus 1 v into z minus 2 into derivative of u అంటే 1 minus u into z plus 2 into derivative of z minus 2 v కదా అంటే 1 by v square z minus 2 whole square. Simplification here, limit z tends to minus 1, so that is equal z cancel minus 2 minus 2 minus 4 by z minus 2 whole square. Now substituting z is equal minus 1, that is minus 4 by minus 1 minus 2 whole square అంటే 9, that is minus 4 by 9. This is the required residue of the given function at the pole, that is equal minus 1 of order 2. This is a to finding residues of the given functions. Okay, you understood? Yeah, okay. For more videos, please do subscribe my channel, like and share it, and give the comments in the comment box. Anyone is also will clarify any doubts in the, you do any comment. Okay, thank you.